Section 2.5 Order of Operations with Integers. In this video we will review rules guiding order of operations and how to evaluate integer fractions and how to evaluate absolute value expressions. For convenience, we repeat the rules guiding order of operations first introduced in Section 1.5. When evaluating expressions, proceed in the following order. 1. Evaluate expressions containing grouping symbols first. If grouping symbols are nested, evaluate the expression in the innermost pair of grouping symbols first. 2. Evaluate all exponents that appear in the expression. 3. Perform all multiplications and divisions in the order they appear in the expression, moving left to right. 4. Perform all additions and subtractions in the order that they appear in the expression, moving left to right. Let's look at a number of examples that require the use of these rules. Example 1. Simplify a negative 3 squared and b negative 3 squared. Solution. Recall that for any integer a, we have a negative 1 times a equals negative a. Because negating is equivalent to multiplying by negative 1, the rules guiding order of operations require that we address grouping symbols and exponents before negation. Because of the grouping symbols, we negate first, then square. That is, a negative 3 raised to the second power equals a negative 3 times a negative 3 equals 9. In b, there are no grouping symbols in this example, thus we must square first, then negate. That is, we have negative 3 squared equals a negative times 3 times 3, which is a negative 9. So, with the parentheses, we have the whole expression negative 3 being squared. Without parentheses, we can only assume that 3 is squared. Example 2. Simplify. Negative 2 minus 3 times the difference of 5 and 7. Solution. Grouping symbols first, then multiplication, then subtraction. Perform subtraction within parentheses. 5 minus 7 equals a negative 2. Then multiply 3 times negative 2 equals a negative 6. Then add the opposite. Change negative 2 minus a negative 6 to the addition of negative 2 and positive 6, which equals 4. Example 3. Simplify a negative 2 times the difference of 2 and 4 squared minus 3 times the difference of 3 and 5 cubed. Solution. Grouping symbols first, then multiplication and subtraction in that order. Perform subtraction within parentheses first. 2 minus 4 is negative 2, and 3 minus 5 is negative 2. Exponents are next. A negative 2 squared is a positive 4, and negative 2 cubed is a negative 8. Then multiplications are next. Negative 2 times 4 is a negative 8, and 3 times negative 8 is negative 24. Add the opposite. Negative 8 minus the negative 24 becomes a negative 8 plus 24 equals 16. Example 4. Simplify negative 24 divided by the product of 8 and negative 3. Solution. Division has no preference over multiplication or vice versa. Divisions and multiplications must be performed in the order that they occur, moving left to right. Division first. Negative 24 divided by 8 equals negative 3. Then negative 3 times a negative 3 is a positive 9. Note that if you multiply first, which would be incorrect, you would get a completely different answer. If we multiplied first, we'd have 8 times a negative 3, which is a negative 24. Then a negative 24 divided by a negative 24 is a positive 1. Example 5. Simplify. Negative 2 times negative 3 times a negative 2 cubed. Solution. Exponents first, then multiplication in the order that occurs, moving left to right. So, exponent first, negative 2 cubed equals a negative 8. Then multiplying from left to right, negative 2 times negative 3 would be a positive 6, and a positive 6 times a negative 8 is a negative 48. Evaluating fractions. If a fraction bar is present, evaluate the numerator and denominator separately according to the rules guiding order of operations. Then perform the division in the final step. Example 6. Simplify the following fraction. Solution. Evaluate the numerator and denominator separately, then divide. So in the numerator, do parentheses first. 2 minus 4 is negative 2. In the denominator, multiply 3 times the negative 5 equals negative 15. Then in the numerator, the exponent, negative 2 cubed equals negative 8. And in the denominator, add the opposite, change minus negative 15 to plus 15. Then in the numerator, multiply 5 times the negative 8 to get negative 40. And in the denominator, add negative 22 and 15 to get negative 7. Then in the numerator, add the opposite, change minus negative 40 to a plus 40. Then in the numerator, minus 5 plus 40 equals 35. Then divide. 35 divided by negative 7 is a negative 5. Absolute value. Absolute value calculates the magnitude of the vector associated with an integer, which is equal to the distance between the number and the origin 0 on the number line. Thus, for example, absolute value of 4 equals 4, and the absolute value of negative 5 equals 5. Absolute value is always positive. But absolute value bars also act as grouping symbols, and according to the rules guiding order of operations, you should evaluate the expression inside a pair of grouping symbols first. Example 7. Simplify a negative negative 3 and b negative absolute value of negative 3. Solution. There's a huge difference between simple grouping symbols and absolute value. In a, this is a case of negative times a negative a, which equals a positive a. Thus, negative times a negative 3 equals a positive 3. The case in b is much different. The absolute value of a negative 3 is positive 3, and then the negative of that is negative 3. So in symbols, a negative times the absolute value of negative 3 would actually be a negative times a positive 3, which is a negative 3. Example 8. Simplify negative 3 minus 2 times the absolute value of the difference between 5 and 7. Solution. Evaluate the expression inside the absolute value bars first, then multiply, then subtract. So remember, absolute value symbols are like grouping symbols. So we would evaluate in the absolute value first. So subtract inside the absolute value bars. 5 minus 7 is negative 2. Then take the absolute value of negative 2, which would be positive 2. Then multiply. 2 times 2 is 4. Then negative 3 minus 4 is negative 7.